Single-use medical and surgical face masks and the N95 mask are usually composed of wool felt, fiberglass paper or polypropylene, which trap particulate matter through an electrostatic charge embedded deep in the fibers. Several scientific studies have been conducted on how best to sterilize single-use face masks. According to academic papers, the electrostatic charge can be damaged when washed with soap and water due to the mechanical strain on the fibers. Other sterilization methods tested include the use of alcohol, hydrogen peroxide, steam, and UV light. Several studies conclude that the most efficient way to sterilize these masks and still maintain the filtering properties is to heat them to 70 degrees for at least 30 minutes. This effectively destroys viruses and kills most bacteria. The pouch consists of 5 layers, each increasing 5 mm in size, to fit snugly inside each other. The innermost layer is made from Vilene L11, a thin, non-woven material to filter fluff and loose fibers from the adjacent layers. The second layer is made from Insulation Bright, an insulating foil with hole-punched wadding. This layer is embroidered with 1.8 to 2 meters of 0.45 mm PTFE coated nichrome. The nichrome is held down with a zigzag stitch. The pouch is first sewn down the edge. The seam is then moved to the centre and is stitched closed. The bottom seam is opened and the corners are stitched around 2.5 cm from the edge. This will give the pouch its height. The open ends of the nichrome wires are connected to non-heating wires which will later be attached to an adapter. The third and fourth layers are constructed from the same material as the second. After construction, they are flipped inside out. The final external layer is made from a durable heavyweight cotton. It's 5 cm longer than the others, with the excess fabric used to fold over the edge at the top. Before the bottom is stitched together, an eyelet is placed for wires to feed through. It's then finished in the same manner as the other layers and finally flipped inside out. The wires are fed through all layers and finally through the eyelet. The 5 cm excess fabric is folded twice and then stitched around the edge of the pouch. Finally, Velcro is added around the opening of the pouch to seal it tight, and a hoop is sewn for the bag to hang from. The pouch is now finished. This is what the timer module looks like. Based on research, we set the timer for 60 minutes, allowing 15 minutes to reach 70 degrees, and 15 minutes extra to make sure heat is distributed evenly over the entire mask. We use a 12-volt adapter. It's wired into the UCC and ground of the timer module. A regular switch will be added, allowing the user to turn the entire system on and off. A thermal switch will be added to the heating wire, which will regulate the temperature inside the pouch, preventing it from overheating. The finished pouch is now ready to be added. On the right side of the timer module, one end of the pouch is connected to the on port. This powers the pouch. The other end is wired into the ground. A 2000 ohm resistor is also wired into the on port. The resistor is wired onto a red 3-volt LED which will indicate when the pouch is sterilizing. A push button is connected to the timer. When this is pressed, the LED turns on and the timer starts its countdown. This is all placed in an electronics box where the LED and push button are visible. The pouch and electronics are now connected, and the pouch heats for 60 minutes once the push button is pressed. The temperature reaches 70 degrees and equilibrium after about 15 minutes, and the timer cuts off power after 60. You are now ready to enjoy your delicious mask piping hot from your pouch.